Hi, good afternoon. Uh, I hope all the people who are attending our webinar are safe with their family and keeping well. Uh, we are here again with a new point of discussion. Last time we had a webinar where we made a discussion about precast construction as a generalized topic. In the StruEngineers, we are making a lot of efforts to make awareness about precast construction, and also we are giving a webinar about our product, which is like software and services, minimum once in a month. So this is a general webinar which we will be talking about a project where we use 3D modular precast or PPVC precast construction. So I think we should wait one more minute so that we can have more attendees before we start our discussion and we take the project forward. So basically, the idea of PPVC construction or the agenda of today's webinar is to give awareness what are the current trend of construction industries. Yeah, definitely. Somebody will say that 2D precast still is not using as per its capacity or as per requirements in India. And today we are talking about 3D precast. But don't we should get our prepare ourselves before the time? Yeah, so the agenda is to have to keep people give awareness about 3D precast, and we will show a case study where we have done complete master layout of around 200-acre township, and how we were able to make the structural design for these 3D modules. So I think we can start now. Before we go in details, we will start with a brief introduction of our company and our today's presenters. So we are StruEngineers India Private Limited, and today our associate company, Sahyog Designway, we are both working very closely on a lot of precast projects, and we are giving this webinar where we work on a project. So StruEngineers, we are part of Skanska from Sweden, which is like world fifth largest construction company, and we have a spin-off IT office of uh, Skanska by the name of StruSoft, where we are providing softwares to monitor precast operation, designing, analysis, and all different like energy analysis and all different things. So uh, we are having our office in India from 2011, based at Pune, from where we are giving our structural design services. We are providing structural support and precast consulting services. StruEngineers, like if I say about independent company, we have office in India, UK, Sweden, Manila, and uh, then we have office, as I mentioned, office in Pune. So, what services we are giving with our from our Pune office are, I will just talk about those services. Yeah, so we are providing complete design turnkey solution under one roof. We have very much expert team, especially in precast projects. So if you are planning any project, let's say even it's a cast in situ or a precast, but as I mentioned, we have expertise in precast. So from scratch to finish, we can give complete support for your projects, and we can talk in terms of conceptual ideas. We can give you a complete master architectural planning for these projects. We can provide only if you want only structural support, or if you just looking only architectural uh, services. We can again provide complete support in terms of if somebody want to establish a precast plant, and we can really help them in consulting about their requirements. We can really help them to start a plant production in a very economical way. We have a team where we have people of equipment background. So we can really help you to set up a precast plant very economically. And so today we have our presenters, Mr. Suhas Mohol. He is managing director of StruEngineers. He is having around 20 years of experience in structural designing and value engineering. And from our own team, Mr. Mangesh, he is having 8 years of experience. He will be talking about how he did structural analysis of these 3D PPVC modules, how we were able to develop these uh, how we were able to develop initial structural analysis. And for architectural point of view, we have Mr. Anand Sabu. He is director of uh, company Sahyog Design Way, and this company under this company he is doing infrastructure projects in terms of like he is into like concept planning, he is into complete product planning and all the like master layout development. So he will be talking about how we were able to develop these project uh, with the 3D PPVC construction. And we also have Ms. Khushbu Bhatt. She is having 4 years of experience, and she is having expertise in building energy calculations, which is very interesting topic. You are going to see in this coming time. A very interesting session is going to be for 1 hour. So we have today's agenda. We are going to talk about introduction of PPVC 3D precast. What are its advantages and what are the requirements? Some people may think that a country like India, where we have a population of around 1.3 billion, and we are talking a technology which merely require uh, any labor or any people at the site. So that is the idea. We'll be talking about why we require all these number of people and why it is required for current scenario in India. We will also talk about how all these structure analysis, how these case study about New Zealand Canada mass housing project, how this modular construction was planned, how the master layout was done, and how our team was developed, the connections for this 3D precast modules, because connections are very critical in precast construction. We will be talking about BIM implementation for this project, and also how we were involved in setting up a precast plant, which was really eye opener, how one can really reduce the precast plant investment. And we will take your question answer after the session. If somebody want to have any question in between, they can put their into the comment box. And uh, I would like to invite Mr. Anand to take this session ahead. He will be talking
Yeah,
about this master plan development, and he will be talking about how the modules with the different sizes we were able to make during this project.
yeah,
Mr. Anand, you
yeah. Thank you, Sandeep, for detailed introduction and creating a right platform for today's discussion. Yes. So I'll just briefly talk about myself. I'm Anand Sabu, and good afternoon and hello to everyone all across the world. This times are really exciting times, and here we are coming up with talking about an exciting technology. Before that, I'll just briefly talk about Sahyog. It's a design company which has grown multifacets. We do space design, master planning across the discipline. One of the biggest forte of ours is 3D precast constructions and energy efficiency. Uh, we do also urban level master plan signages, the retail modular structure, and of course, we develop product design. So coming to our topic today of 3D precast, why today and why it is important. Today, our population in 2021, we have reached 7.9 billion. Uh, I'm not talking about India only; it's across the world. India, we are closer to 1.3 billion people, and today, of course, certain areas of world we don't have democracy. Recently, we have looked at Kabul, how things are going on, but then we have democratic structure, and all across the world, this is the time when we have democracy and 7.9 billion people, and everyone would need housing, commercial space, indoor space to work, and this technology of 3D precast has benefits of time, production, fast production, accuracy, resource efficiency, energy responsiveness, and much more. Of course, that's what we are going to talk about here. And there have been good examples of this buildings all across the world, where this 3D precast has been used in hotel industry, hostels, uh, and nursing homes, which are there. Today, to talk about it in much more in detail, we will be looking at uh, two examples of projects which we have worked in, and we are going to take a world scenario today. And this technology is not only going to provide solution to Indian growth story, the which is there, but also the world housing requirements and construction requirements. So the two projects which we are going to talk about, one which is there in New Zealand, which is there, uh, which is down under, and second down up, not down up in the Canadian location at Nunavut, which is there, and both are different extreme climates, and there we come across. Okay, so I would start with the first part, which is the New Zealand. Uh, this is a aerial view master plan of that location, which is there, uh, which is somewhere around 0.95 square kilometer of master development, which is there, and uh, the development. And there we have used the 3D precast as a core structural, core construction technology. And then how we have come up with various typologies of bungalows which are there, and that's what we are going to talk about the same. Of course, the hierarchy of the wind velocity and other things, and how we have planned the structure. That's what it is shown, and the various module types and details which are here. So yeah, the master plan, of course, it has an urban feel to it, a basic approach of how the road networks, the landscape, the green, which is the really important part in today's world, and the build structure, how we have integrated all of them. And these are few views of the township, which is coming under. Uh, so whenever we think about development of any sort of construction or anything, we need to understand human lifestyle. And these are the six basic parameters on which it was designed: the health, entertainment, environment, community building, ecology, and the safety part, which was incorporated in the development of the master plan. So when we look at it, how we place the amenities which are there, the maintenance part, which was at 250 meters across any distance which you look at. We have security, dispensary, daycare, green clusters which were there. Amenities which were 500 meters above, the children's play area, the senior spaces which are there, fire department, fire stations which were at 500 meters, and then the entertainment, swimming, indoor stadium, play area, which were at 750, and that comprised the complete development of the master plan. Uh, a small brief behavior of the road and infrastructure which uh, a master plan requires, which has all the disabled access, the road access, the cycle tracks, and everything, which were rightly indicated in the right proportion to match the lifestyle of the human being of a developed country, which is there. Now coming to the design philosophy, which is there, one of the most important which is there is sustainability, which is most important and which is at the top. The second part, which is the structural stability, which the lightweight, the modular structure, durability, and cost effectiveness, which 3D precast brings across with it, and the low maintenance part, which it brings across. and design has the comfort, experience, and social interactivity. So coming to the sustainability part, which is there, we had approached it towards net zero energy, which is there. We have a passive design strategy and active design strategy. Active design includes energy efficiency, equipment's usage, and other parts, but are more focused during the design of the precast elements was more about the passive design strategy, which was optimizing orientation, cross ventilation, daylight, uh, and better heat transfer into building part. As we look at design, passive design strategy, which Khushbu is going to talk about, how building also breathes. In the daytime, it takes in the heat, which is outside, and in the night, it precipitates heats outside. So we have to have a breathable building, which has to be designed, which is there. Now coming up to our design solutions, which were there. So there were five different types of design structures which were there: modern bungalows, which is this modern bungalows part, modern detached housing, semi-detached housing, three-story and 12-story, and how we have gone across it. So when an identification of the site, which was there, the sizing, the activity chart which comes across, and then the built design. And then we came up with a design solution, and then how the 3D precast structures were placed across it. So the second part to the design is this 3D precast structure, the details of the modules which were placed, logged in to create a complete volume, which creates a livable space which is inside. And that's what is shown in this detached part in the module details which are there. Then second is modern detached setup, which is there. Uh, so I take the similar story of design where we have used the services, what sort of uh, interactive spaces which we need, and using the same module structure. Okay, so same module structure which is here, and created a 3D which has different language, different services, but having the same structure placed in the same placed and created a different dynamics of it. Okay, and then we get this modern detached housing facility. Now, as we go further, this is a semi-detached. So we had seen a modern bungalow, a detached part and a semi-detached part. It's more a twin bungalow setup, which we call in India. So here we have again looked at the same hierarchy of spaces, which comes across the placement and alignment at the side, and then used the 3D structure which we had optimized, and come across with module design details which is there, and then how they are placed together to create a differential elevation which is there, and then all the three which we have seen have created a similar volumetric space inside, but the elevation and the experience and the composition of that volumetric creates the difference here. Then we had three-story apartments with three-bedroom structure, which has a common facility, private space, and the modular space, which is there, which creates this sort of cluster, which is there, and that cluster creates this apartmental building. And then how these modules were placed with one another in 1C, 1DX, 1D, 1AX. So this becomes a connective design for it, and then this structure uh, has, and of course this module details which comes across uh, and create this three-story apartment which is there. Similarly, when we look at 12-story, which was a two-bedroom structure, which is there, keeping the same sort of understanding of design, how to align things, services, and everything to take to together. We have developed a two-bedroom apartment, which is a 12-story building. the cluster details, how they come across, and then the volumetric 3D detail which is there, and how they are interlocked together to create that sort of space. And so then coming to a detailed understanding how we created a small video of softwares which we use to do this. So this is a 3D module. We use the software of Graphisoft ArchiCAD, and how the modules, which at present we are showing just a block module, but then we have a complete detailed 3D module which is placed together to create this volumetric approach to go ahead in this detailed design. So this is for a apartment part which comes across, and how we are placing it at this point of time to create a volumetric understanding of that thing. Of course, at present we are showing it as a block thing, but then we have made all the apartment 3D molds which comes together, and when we run a simulation in this, it gives us where the connections of this has to be created. And similarly, a 12-story apartment which is there. So just a glimpse of it to have a better understanding. And then you have for a bungalow apartment. So the sizing, if you can look at 7.5 meter by 3.5 meter and 3.5 meter height. That's the volume of one PVC 3D precast module, which is there, and then making it into a module of different types which are there. So this is one sort of demo of the how you use technology to create this volumetric understanding, and then when you run a simulation, you get across the permutation combinations rightly, and you come up with a fair design solution to it. Now the most challenging part, coming from down under to top up to the Nunavut, Canada area. Here there is a place where the climate is from 40 minus 40, which is there. So there we have to of course there are no trees and other things, environmental part, but of course the services are still there. So I'll just brush through it. The solutions which we came up with was four types of different buildings. One was duplex, fiveplex, bungalows, and detached. Here also there was certain sort of requirements which they have. It was more a mechanical cooled building. The wall thickness, the frame was different. So how we have used it into a duplex house layout. So here, when you look at a duplex house, we have used two types of modules to create a duplex house, which was there. Then we look at fiveplex, that's five dwelling units together, which is there, a typical layout of how we have developed the layout, and then the module which is there. So when you see the left, we have the duplex part, which is here, and then the fiveplex, how it gets included into it, and then we have the fiveplex, which is there. Then we have the bungalows, which is there. The bungalows has a different sizing, different number of people staying into it, and different details to it. And how we have kept the bungalows, it's a ground plus one structure, and then we have a module type A, B, and C, and we have created a bungalow out of it. Similarly, to look at the detached housing, which is there, uh, we have used other, of course, this is also G+1 building, which is there, and then how we have incorporated details and detailed out this part of the building, which is there. And this is how we have used three modules, which are there, and created a complete cluster out of and having a different typologies of building. So this is where I just wanted to explain you two parts that we have looked at somewhere 1,400 housing uh, requirement in New Zealand, and 100 550 housing requirements in the North Canada, and that's where the scale and modularity provided this solution, which is there. Now I will invite Khushbu, who is there. One of the important part here in the projects when we look at energy, uh, the energy design solution reduces somewhere between, for us when we look at projects, reduces between 50% to 70% of your energy requirements. If we wisely use this part in our design sensibilities, it could create that much energy efficiency. Energy efficiency means resource efficiency, and the resource efficiency what 3D precast also gives. Optimum use of material, rightly manufactured, rightly composed, and then you have a right solution. So the material, the resource efficiency, and the energy efficiency goes hand in hand. Thank you. Thank you from my side. Uh, uh, and next, I'll hand it over to Kushbu.
Thank you so much for inviting me over here. So I'll just give my short introduction. So I'm Khushbu Bhatt. I'm an architect and I have done my master's in building energy performance and I'm working with Sahyog Design Way as a building energy analyst. So in today's presentation, I'm going to talk about the climate analysis, facade treatment, building envelope, and the carbon footprint. So yeah, one thing I would like to add is throughout my presentation, this blue band represents the Nunavut, which is located in Canada, and this orange one is for Auckland in New Zealand. So in the climate analysis, we have done the dry bulb temperature analysis. So here you can see the temperature of three cities, Auckland, Nunavut, and Delhi. So in Nunavut, we have the highest temperature range, which is from 25 degree minus 45 degrees Celsius to 8 degree. Whereas in Auckland and Delhi, it's 0 to 24 degrees and 4 degree to 40 degrees. So, and then we have done the relative humidity study. So in Auckland, we have the average value high throughout the year, as you can see in the upper plan. And in lower graph, it is shown that in the Nunavut, we have the higher RH value during the summer only. Then we have done the thermal comfort study. So this is the scale to measure the comfortable hours during the year. So in Auckland, we have 40%, 48% hours comfortable annually, and 40% are just short period comfort. Whereas in Nunavut, there is no comfortable hours. So we have to design our buildings with more various strategies. So basically, these are the list of the passive strategies that we have applied in both the case. So as Auckland is more comfortable and its environmental condition, so we have provided natural ventilation and in the mechanical system we have increased the ACH, that is air change per hour, and whereas in Nunavut, because of the cold stress, we have provided high thermal mass with a high thermal performing glazing system. We have optimized the WWR, that is window to wall ratio, and we have provided appropriate heating system. Then to understand the exposure of a sun, in both the case, we have done the radiation analysis. So, and accordingly, we have designed the form of a building. So, in the left side, this is the radiation study of Auckland, very, only for a one day from 6 a.m. to 6 p.m. So, here you can see that the radiation is very high, but for a shorter period of time. Whereas in Nunavut, the radiation is not much, but it is for a longer period of time. There will be no dark in the night also. Then to treat our facade, we have done the window to wall ratio analysis from 20% to 50%. And based on that, we have provided 40% window to wall ratio. And here, these are the graph which is showing the heat gain through window and its impact on the total building energy. So EPI is the basically the energy consumption of any building, and building are rated based on that only. Then similarly, we have done this study in Nunavut also, and here we have selected 10% indoor to wall ratio to reduce the thermal conduction. And we have done the daylight analysis. So these are the plans which are showing the illuminance on the working plane. So in the left side offline we were able to achieve required daylight because here the window to wall ratio was enough. Whereas in Nunavut, because of the 10% window to wall ratio, we were able to achieve daylight for only two spaces. Then coming to insulation study, for the offline, as per the standard, we have designed the building envelope, and we were able to achieve required U value just by providing the concrete. Whereas for the Nunavut, it was very challenging to achieve required U value because here the U value was very high, 0.12 for a wall and floor, and 0.09 for a roof. So we created different options for all the elements. And so when we were experimenting with different assembly, we were getting very high wall thickness, around 2 feet. See, so we wanted to reduce the thickness of a wall. So we studied different insulation and its property. So and didn't wanted to reduce the thermal performance. So based on the different study, we selected aerogel insulation, and with the high performance concrete slab, we were able to achieve 0.012 U value with only 185 wall thickness. Similarly, we have done all this study for all this building typology. Just because of the time constraints, we are showing you just one example over here. Then coming to carbon footprint. So here I would like to start with why we need to study this carbon footprint. So as we all are aware about the environmental impact that we are facing nowadays, like rising temperature and the climate change. So for that, the carbon dioxide is the most important greenhouse gas. And for that, the building and construction sector is responsible for 39% of all carbon emission in the world. And in that, the operational carbon emission is responsible for 28%, and the remaining 11% comes from the embodied carbon. So, what is operation carbon and the embodied? So, embodied carbon is basically the manufacturing, transportation, and the installation of a building materials. And the operational carbon is the carbon emission when building is in operation mode. So embodied carbon generally accounts for a 30% of a total carbon footprint, and which is produced in just 1 to 2 years, and the remaining 70% is producing 25 to 35 years during the usage of a building. So per year, if we see this embodied carbon is more, so we need to more focus on the embodied carbon. So these are the different stages for to calculate the carbon footprint. Like when we are getting the raw material, when we are using it, and after that we are recycling the material. So these are the different stages. And based on that, we have done the CO2 carbon comparison. So with this 3D precast technology, during the all this stage, we can reduce the carbon footprint, and all over with this technology, we can reduce around 14.5 carbon footprint per cubic meter. So yeah, that's it from my side. Thank you. And
Yeah.
here I would like to just add one thing. By implementing the energy analysis, we can also reduce the electricity consumption generally by 30 to 40% with the right design.
Hello everyone, good afternoon. I'm Mangesh Tumar, going to give you my experience on how I design. First of all, I'm a senior structural engineer in StruEngineers. So for the 3D PPVC, the design content uh, is weight of the size and weight of the module, and the design steps. Then what were the project challenges we got? Then a small introduction on casting process, how it's done, and then the project impact manager will give an introduction on that how it's done in there. So starting with the size of the module, size and the weight of the module. The size is actually in normal precast or any in situ part. Architectural decides the sizes of the rooms and everything. But here, the transportation is the main issue of the whole module. So it is decided on the how the module will be transported from the manufacturing plant to the site. So basically, trucks are used. So trucks have some sizes restriction, which is generally height of the module, or the size of the module should be less than 4.5 in height and in width 3.4. So for the truck, it can carry about 80 tons. So, but the lifting is done by the cranes. So cranes have the maximum crane capacity available internationally for the modules is 35 tons. So the restriction while designing the module was 35 tons. We have to not go beyond the 35 tons. So for designing this, we had first step is framing plan. So in framing plan, obviously common column, beam, slab is generally used, but we have to use walls also, and the combination part of that. So how are this used? Like it depends on the opening which is provided by the architect, and the weather conditions there. So according to that, we have to go for that. And the second is what type of building it is. Like if it is 1 story G plus 1 story, so we can go with the normal column beam slab structure. But if it is multi-storied, we have to go for both kind of structure, slab and beam, slab and wall, and column beam slab. So there is a combination of that. So in this, basically the weight is the concern. So the weight of the column beam slab is lesser than the wall slab module. So we have to decide on the part of that. After that, the second step is uh, the individual module design, where every load, vertical load, lateral load is actually taken part. But the governing part here is lifting. The lifting part, we have to do a design like how it will be lifted, how it will be lifted in on site and on the manufacturing unit. So generally on site is lifted by the lifting frame uh, on on site, and the lifting frame is used to match the CG of the steel frame and the module. And all this design analysis is done by FEM design, which is software developed by our StruEngineers and StruSoft engineers. After this design, we have to go for the combined analysis of all modules, like cluster analysis of whole modules. So it is generally done in FEM, FEM design also, and also in ETAB. But has a lot of annexures of every country. So ETAB is more suitable. But FEM design can also be used by calculating individually the loads and assigning those loads on the building. So it can be used. So during ETAB analysis, it is designed for the whole lateral load like wind load and earthquake load. It is designed for that. And vertical load, we have to just check that whatever steel we have provided is fine, or we have to revise it. So it's done like that. So to that, the project challenges which we got in, like Khushbu mentioned, and also Anand sir also mentioned, that we were working in two extreme conditions like New Zealand, where for the structural part, the earthquake is more there. It is very governing there, and in Nunavut in Canada, the it is very cold extreme climate. So for that purpose, we had a challenge to make walls, sandwich walls for the extreme cold climates, and also with that we have to module the sloping roof. So while designing that, after finalizing the design, we got the module weight as 80 tons. So we have to make it lesser to 35 tons. So for that, we got a solution. We have to design it like a slab, uh, like column, beam, and a combination of all the three structures which I mentioned in the framing plan, which is in this slide. All this we have included in it. The columns were included like a local thickening we give. Uh, Here, if you see the screen, there is a this is a kind of column. It acts as a structural stability unit, and other part is as elements. So we had to go for this kind of for the vertical system, or for the horizontal system we have to design it inclined slab, and all this had to be designed in FEM for lifting also. That was the major challenge, and we this drastically changed the weight of the module to 35 tons, less than 35 tons. So after that, uh, the main part in precast is connections. So connections in this case, for the module connection, other connections are similar, but the module to module connection is very important. So it should act monolithically. So as you, we can use same system which we use for the wall connection in precast, but in this case, towel will go throughout the wall and will be anchored or screeded in the topmost roof level to have a monolithic action. This is the special thing which we can use there in for action of monolithic action. After that, how this production of this PPVC, 3D PPVC is done in manufacturing plant and then erected on the site. First, we have to make a main frame, which is 3D module of all the concrete framing and elements, slab, wall, anything. And after that, all the fixtures of windows like MEP fixtures and architectural fixtures, then it's ready to transport to the erection plant. And at the erection site, there is transfer slab. On that, the erect this 3D modules are erected, and this is how it actually goes. Everything is done in manufacturing plant, and this is then erected directly on the site. Structural modules and the services, everything is done in manufacturing plant, and only connection part like grouting and screeding is on the site. That is the special thing about this 3D PPVC. So next is like how this is managed in our beam contact beam impact of software will be introduced by director Suhas sir.
Thank you, Mangesh and project team. Uh, it was really a pleasure working with you all on this project. So before proceeding the beam, what we applied here, the beam environment, I would like to make some summary of this project. Uh, yeah, certain challenges were there. Like client came up to us and said, I have a certain acre of land and I want to develop structures. And then he mentioned, I want these many story structures, these many houses. And then he just threw the number. But then our architecture team came up with ideas, and then it was about selection of technology. And then, yeah, no doubt, precast was the one governing technology. But again, we thought about we use a 2D segmented precast or 3D. So we saw a lot of advantage over 3D because of the climatic challenges and the factory environments. Because in New Zealand, there was a challenge of the wind speed and especially the seismic forces. And in Canada, it was the cold climatic conditions, so it was Arctic region. So we found technology more suitable. We gave this idea to client. He accepted it, and then again, other challenge was to do it in a very short time. So we team up together with architecture and structure team and provided And again, we found during the project, as Khushbu mentioned, the carbon footprint. And we found, yes, there is a lot of energy saving and a lot of emission of carbon has been saved. So that was again a very big achievement during this project. And again, one more important part was the podal provision, because when we come to New Zealand, then there was a seismic. So the connections, the jointing, as Mangesh said, are different than the Nunavut. And again, the insulation part, where the energy consumption, when we are heating up the building from inside. So this insulation part is very important when we come to Arctic region. So both the projects were in a different challenges, but we could do that with our great teams here. So what are the benefits basically? It was just 100-acre land and we just had to develop it. But one basic value addition we bring to the table for client is like we have a great knowledge of machineries, precast machineries, and that's where we team up with our expertise in house, and then we provided solution like which should be a good technology and which should be the, because client had approach other machine companies in different areas, but we gave them a very customized solution, and that is where we really benefited our client, because his budget was X and then we really saved a lot of amount on his machinery parts. Then, of course, under our StruPCS brand, uh, all the all the machinery or equipment, and then when we are talking to a client, we are talking as a team. We are in-house architect and structural team where there is no iteration of information, because all these teams are works in a tandem, and that really save time and money for the client, and that is where precast is very important. I mean, when we are adopting to a precast technology, we need to have certain rules or terms to be set up from the beginning. Otherwise, there would be a lot of challenges when it comes to architectural planning and structural design. But that's how we really made up our teams, and we really pass on that benefit to the client. And yes, the 3D technology, the precast 3D PPVC was really useful for the client in this case. So yeah, and then we offer our own system, Impact Beam, for delivering on this project. And if I go on to the system, so I just would like to throw some knowledge in 2-3 slides here, not taking much time. So Samuel, just few names I use here. Samuel is a detailer who is working from home because of the pandemic situation, and that was the forced situation. And then Patrick is in the office. He has to come to the office to do the planning. And Ben was a production foreman in the factory. And all these stakeholders, all these parties should get together. Otherwise, there would be a lot of miscommunication might happen. And even we are connecting Alan, a logistic manager here. So how these are connected basically through our Impact Beam. So all the database, the Impact Beam database is in the center. So we hosted everything on the cloud, and irrespective of our location, we could connect. So even our architect team was looking at the project or the client or the detailers to designers to the logistic managers and project manager. So Samuel was doing the modeling, Patrick was doing the office planning or project planning, and this is how they were connected together. Then little bit about our Impact. This is a database where we connect various softwares, and that's the open beam technology. So we have connection to Tekla. We have own development tools where we can use Revit or AutoCAD to bring up these models. So in this project, we use AutoCAD. Then we can bring up Excels or XML files to create certain database, and then we can throw data into IFC. So this is how all the technologies were put together. So Samuel, this is a snapshot of this New Zealand cluster. So like 12-story apartments, and then 5-story and 3-story, and some small houses as well. Then Patrick was doing the planning. Once he got the whole model from Samuel, he was doing the planning for that project. Here I'm showing hollow house, but yes, then there were 3D houses what we planned together. Then it was some logistic planning also. Then Ben was a factory manager, so he was looking at the production, and he was doing the quality checks using our Impact Mobile application. So I'm running a small short video here how that been used. So this is our mobile screen, and this is Impact application. So now he's doing the quality control of those elements. Now he found some issue on particular corner of an element. He took the picture from his mobile, and he logged that picture into the system there. And now he's reporting that with some text and some explanation around that. Uh, After that, that information will go. So he has added a couple of pictures to be more evident. So that information at the same time simultaneously came into a resource manager, where resource manager was like having a list of checks, and then he found that check. Okay, this was the issue. Uh, then he checked with the factory guys or the production guys, and then he resolved that afterwards. And then he also reported back to the person on the who reported that, so that they have a very good way of communication among them. So this is this was and then Alan, who is a logistic manager. So this, as Mangesh said, the transportation is very important, because the main governing factor here was the capacity of the trucks and the cranes which can lift the elements. So Alan was the one who was doing all the logistic planning, and then he was having access to the system, and then he was checking the weight of the modules and whether those are permissible on the trucks or crane. This is how they united together, and it was really benefited and this is how we adopted the beam technology with our software Impact. So that's all from my side. Thank you. So I'll just pass it on to Sandeep for further presentation. Thank you.
Team, for making such a nice presentation.
Yeah.
So, rightly mentioned, our scope of work was initially consulting about the project architectural planning and developing the structural designing and modules. But later on, we got to know that the client is having very less or no knowledge about this precast construction. So we have a department called StruPCS, in which we are helping our clients to implement precast technology for their projects. And it's not just the project should be of millions of square foot or thousands of acre. If somebody is planning to make a construction of, let's say, 200,000 square feet every year, so he can also set up a precast plant and he can use the technology and get all the benefits. So I'll not take much of time. I'll just give a project in very brief. So this our particular client, he was not having any prior experience of any concrete construction. He was coming from a timber construction background, and he actually wanted to have this mass housing project in New Zealand and in Canada. And initially, like, he told us that he want to set up a precast plant in Canada and want to uh, transport these modules to Canada. So from Canada to New Zealand, which was almost 8,000 kilometers and 90 days transportation time. So we really made a lot of time meetings. There were a lot of like time difference. Mostly we were having these meetings in night time, when in Canada it was like morning time. So we try to understand him, his requirements. And though we found that maybe 2D construction would be flexible would be very easy because of flexibility, and due to like there is less challenges in 2D precast in terms of construction. But he said that especially in Canada, the location he was uh, situated, like he said that I do not want much work at the site. I want that the most of the work should be done in factory, because we just learned during our architectural presentation that the temperature goes up to minus 45 minus 50 degrees in the like during the winter session. So we thought to like do a bit study about this area and locations, and then we really found that 3D precast construction would be a viable technology and viable option for this kind of project. And it was not a very small project. In Canada, it was around 212-acre mass housing project, and in New Zealand, like it was around 216-acre township. So for New Zealand, he really like he has already bidded for this project to the government, and to make his bidding more comfortable and more strong, we made a JV agreement also with an Indian company who is having good knowledge about precast construction, and they are like financially strong as well. So like we helped our customer out of the box and what was not in our scope. And there were a lot of technical meetings which we made to the universities to get the approvals with the applicators. Like we had a meeting with Sika Canada just to find the right solution for the connections and these uh, grouting and sealant, as like client was not having that kind of technical expertise available with him. So coming back to the StruPCS, we really propose in 3D precast or PPVC modules. And then the next challenge was usually in 2D precast, we have a lot of flexibility, but in 3D, we have to cast as per the mold size. So we engaged with the different equipment supplier, and we really asked them whether it is possible to make a flexible molds. And then we really got a client who can, sorry, vendor, who was really able to supply us a flexible mold with a flexibility of 1 meter. And as per client requirement, we found that we have to construct the mold size of 4.5 meter by 9 meter size. So which means we can construct for 5.5 to 10 meter also with these molds. And then with our architectural department, they made different kind of combinations, and the client wanted to make 4 units every day, means 4 mold production every day, and four mold makes one house for his project. So really it was again a challenging thing, and he does not wanted to have more than 15 people including labor and all the management staff in the factory. So a lot of automation and lot of machine learning things was involved into this thing. So and like he really told us in advance that I am having this limited fund availability. He told us around 4 million euro is budget. But after a lot of discussion with different vendors, we negotiate on his behalf, and we were able to get his precast plant as per his requirement, as per his production, in 5 million Canadian dollars, which is equivalent to 4 million euro. But in 5 million CAD, it was not only precast plant, but also shed. You know this how much expensive this shed in this Canada and all these places. So it was a huge precast factory having a lot of space for stockyard, and the shed and the precast plant in 5 million CAD. It was really, we were able to save around 30% of his investment. So our scope of services was not only just to like stop here. We also helped him to developing a documents like standard operation procedures, construction methodology statement, QA/QC documents. And since he was having less knowledge about it, so it was our responsibility to make him skilled about what he's going to do in next couple of months later. Like right now, his plant is under construction and he is going to start production by March 2022. So we are helping him to like interview skilled people. Some of them we are uh, providing from India, and he's in the process to hire some people from Dubai also, who are people like having good knowledge about this precast and 3D PPVC construction. Some people like in Singapore, Malaysia, a lot of PPVC is happening. So we are giving the filtered CVs, and he's taking all the interviews in this process. We are also putting some of key resources in terms of maintenance, in terms of daily routine checkup, quality assurance, all these things to make the smoother operations so that the project goes successfully. So here are again some projects which we are doing right now, or which we did in terms of consulting precast projects. Just to name, we are doing a million square foot project in Africa, where we are doing complete consulting. We are means helping them to setting a precast plant to make a million square feet a year, and also putting up a 16 key resources at the site who will be helping them for production and erection. Also doing a 5 lakh square feet affordable housing project in Ranchi, which they're again helping them to setting up precast plant from very scratch to finish. Means where we are saying finish means all the shed and everything. So similarly, there are a lot of projects. Recently, we are involved in a project which is coming up in UP. It is 200,000 square feet commercial mall project, where we are helping him to get a precast contractor on board, because for this particular client, he does not want to set up a plant. So we are consulting him how he can really get a precast contractor. We are developing RFP modules, and also we are working on a data center project where the client want to make a 10 number of data center, and we are helping how to implement the precast technology. So why one should go with the StruSoft or StruEngineers? From this case study, you must have learned that we don't work in piece and meals. We give the turnkey design solutions. So the major benefit with it, like there is no clash in terms of concept and ideas. What our architect is thinking, he has already idea that this particular project is going to be executed with these kind of challenges. It is in 2D precast or 3D precast. So a lot of expertise, a lot of knowledge available with us. We are part of Skanska, which is fifth largest construction company. Which like nobody want to give introduction about it. We have experience around 40 years, which is like I think 35 is older, but is around 40 years of experience. We have 1,000 plus customers around the globe, and we are a multinational company which is having offices in Dubai, UK, Poland, Manila, India, Sweden. So we have a lot of resources, lot of expertise, lot of knowledge from different corners or different part of the globe. We don't go for like external agencies for any project. We have all in-house expertise available, and if you really have any project, we can give a lot of initial consulting free of cost, which just to make you aware about the precast technology and how you can get benefit out of this consulting. Yeah, we are running out of time. So we have what we learned from this session. We learned that yes, 3D construction is just knocking the opportunity of our door, and it is after maybe a lot of projects in India are already started with the 3D precast. Just to name, Magic Crate is doing 1,000 housing units in Ranchi under Lighthouse project, which was started by our Prime Minister Modi in January. And also Tata Projects, they did one project in Boisar, which was already executed in 3D construction. And there are like very big projects which are coming in Mumbai. There is a company already setting a plant for 3D pod making plant. And again, another like Godrej, they are also planning to set up a 3D precast plant for their projects, because with 2D it is very difficult to cast a 3D. Like when you cast it 2D and make it 3D, then it is difficult. So people are going to make itself the 3D. So a lot of things are already happening. From this case study, we learned the most highlighted part was energy saving. We are not resource like we are not a country which is full of resources. We are lacking a lot of resource, so we need to save energy. And when we are cooling the temperature, it take 2 units. So if we really make these kind of efforts in advance, we can really help in operation, during the operations or during the life cycle cost of the buildings. If we plan this energy saving properly, we can really save a lot of electricity consumption bills. We just learn that how we can counter the challenges of different time zones, having these kind of cloud-based software where everybody is on same platform. And that is how the exchange of information is quite easy. And from this true PCS, we can really help you to start the precast plant very economically. Yeah, thank you for your time and for your patience, learning us, listening us from very interesting, with a lot of interest. Now, if somebody is having their questions, they may raise their hand or they may ask any questions from our panel. We'll take the questions one by one. Yeah, thank you.
Yes, Sandeep, there is question from Vibor Gupta. Like, how much time did it take you to come up with master plan and the building topologies?
I would ask Anandji. He would be the right person to give answer of this particular question.
Okay. So typologies was something which was given to us, of how what size of housing requirement was, the dwelling unit types and other things. Eh, but then master plan took around 4 weeks of working to come up with the complete master plan, uh, and then a month more to integrate all the units together to come up with a workable module solution which has all the uh, design elements together. Okay, the lifestyle and other things which are there, and then the modularity, which Mangesh and Suhasi talked about, how to have that sort of thing, and that and in a whole, it was a 2 months exercise to come up with a complete design solution, which is optimum, resource efficient, and energy efficient.
Yes, there is one more question. What are the connection details from plinth to wall panel and wall panel to beam or roof?
Okay, it's simple. It's a dowel connection. If it is beam, it's actually a kind of cast in situ connection, beam with module. But the module to module connection is kind of dowel, which I have shared with you in the PPT. Like it will go, dowel bars will go up till the top and will be bolted or either screeded into the roof, vented and screeded into the roof. And the modules will be connected to the transfer slab, kind of same as we connect with the foundation plinth.
Thank you, Mangesh. There is one more question. Where did you get the machines for precast plant?
These are
Uh,
questions. I think Sandeep, you are in a better position to answer that.
yeah. So basically, for precast, there are different vendors, and like there are European companies, they are like some company from China, but usually for these kind of industry setting up, we do not trust on Chinese equipment. And even there are some supplier from India also. So we when we are designing their own good things and bad things, and with these kind of limitation, we really did a mix and match from different vendors. We didn't go for the single company. And even we bought some of the equipment like fabricated items from India also. uh, but while we were doing this exercise, we kept in mind the quality should not be compromised, and we took performance guarantee, and we gave the target that all plants should be operational by this time. And hopefully, maybe however, it's like a pandemic time and all this stuff. The plant will be operational by February and or March 2022. And we can really share those information, like if you really have interest, we can share information with you. You can share your questions or your with our mail ID. We can really share. We'll be really glad to let you know about all this.
Okay, so I think we have answered most of the questions, but anyhow, if you have further queries or if you have any interesting project where you want to adopt this technology, we are open for it. Just give us a shout, and we'll definitely like to interact with you. So you can connect us on StruEngineers.com or either on Sahyog Design Way website, and you can reach to us. We'd really like to help you if you have any interesting project. So I think that's all for today. Really, thank you for participation. Look forward to see you in another session. Thank you very much.
Thank you. Thank you. Thank you, everyone.
Thank you, everyone.
Thank you for your time.
Yeah, if you really have any suggestions, you have our contact details. Maybe you can let us know if you have any further interest you want to understand about precast technology, any project. You can let us know with our contact details, or you can send your inquiry on our website also. Yeah, on behalf of our panel, I would like to thank all of you once again, and we will be daily eagerly waiting for your feedback and your suggestions for a few